Okay, looking at combining or double inequalities now, what you can see here is we've got a string of inequalities stuck together in each of these statements. And we're going to look at which of these makes sense and which of these we can put in the number line once you know what they mean. So, reading left to right, we've got a statement here that says 5 is less than p is less than or equal to 9. So is it possible for there to be a value of p that fits, that's bigger than 5 and less than or equal to 9? Yes, there are lots. There are 6, 6.5, 7, they all fit between 5 and 9. In fact, 9 itself would be allowed here. This is a bit weirder. So here we've got 3 is less than q is more than 4. Now, any statement like this needs to make sense in part as well. So if I cover that up, we've got the bit there that says 3 is greater than 4, which is clearly nonsense. If I cover that up, we've got 3 is less than 4, which is true. But because some variations of this are not right and some are, this isn't actually correctly formed. And the way you can tell that quickly is that these all point the same direction and these two don't. So this one isn't allowed. Here, they point the same direction. So we've got 2.3 is larger than or equal to r, which is larger than or equal to 1.9. Now, again, this one does make sense because r could be between 2.3 and 1.9. There are lots of values that could take. That's perfectly fine. So pointing the same direction looks like a good thing. It makes these make sense. Usually though, we prefer them pointing left, pointing down, so we have small building up to large, but that's not always how we do it. So here we've got our last one to check. 8 is less than s is less than 2. Now, if we've got a number which can be true that 8 is less than it, it's got to be bigger than 8. And if it's bigger than 8, how on earth is it less than 2? So this has got a problem here where we've got the numbers in a funny order. If we get rid of the letter, it says 8 is less than 2. If I get rid of the letter on this side, it says 8 is less than 2, which is clearly a lie. That's a mistake, so that is not correctly formed. So they need to point the same direction, and they need to make sense with the values. Now we can put both of these on a number line, just like we've done with other ones, and we'll do that finally, and then we will be done with this. So a number line has to have 5 and 9 on, so let's just start with 4, 5, 6, 7, 8, 9, 10. So this is a part of our number line, and p is between 5 and 9. So this region here includes p. And just like the single inequalities, sometimes these circles are coloured in. And it's to do with which of these is included. So is 5 part of this range? No, it's not, because we haven't got the equals. Is 9 part of this range? Yes, it is, because we do have the equals there, so 9 is part of this range. So this one should be coloured in. And that's how I display that information on this number line. Looking down here at r, we've got a similar thing. We're in some decimal places though, so we'll maybe start at 1.7, 1.9, 2.1, 2.3, 2.5. So I'm going up in 0.2s here, but it's consistent and equal-ish. There's our number line. And 1.9 is here, 2.3 is here, r is in between them. That's okay. We've got an or equal at the 2.3, so that should be coloured in. We've got an or equal at the 1.9, so that should be coloured in. And we'll label it as r so we know what it is. So you can join these inequalities together to get discrete or smaller chunks of the number line rather than the extended arrows pointing on forever. Have fun with those.